Hello everyone, welcome to my channel. Let's learn computer science. Hey everyone, welcome to our series on computer science fundamentals. Whether you're just starting out or curious about how computers really work, this video is for you. So let's start. So first of all, what is computer science? Computer science is basically all about studying computers and how they solve problems. It covers everything: hardware, software, how the two work together, and they're found in every field: medicine, games, education, etc., etc., everywhere. Think about it: your video game, your school portal, even traffic light signals, they all use computer science, right? Let's first understand what is a computer. Computer is basically an electronic device that takes input, processes it, and gives output. Imagine, you're baking a cake. So your input is all your ingredients, processing is mixing and baking, and the output is the cake. Just like that, computers, they follow this cycle: input, processing, and output. In short, we call it IPO. Okay. Now let's understand main components of a computer. Let's break down the main parts of a computer in order to understand. So first of all, we have CPU, which is Central Processing Unit. It's like the brain of the computer. Like your brain does all the thinking. Similarly, CPU carries out the actual processing. Okay. And further, it has its own components that includes ALU, CU, registers. ALU is arithmetic logic unit, and it performs all the calculations and logical operations. CU is the control unit that directs operations within the computer, sends, control signals, gives directions. And registers, they are small, fast storage locations inside the CPU. Okay. Basically, to store small amounts of data for quick access. Then comes input unit. Now, input unit includes all the devices through which control signals are sent to the computer. For example, keyboard, mouse, scanner, touchscreen, etc. They let us talk to the computer. All our commands, our instructions are sent through input unit only. Then comes output unit. These show what your computer says back. Basically all the results are shown back to us through output devices, whether they are on screen or in the form of hard copies, all done by output devices. For example, monitor, projector, headphone, speaker, printer, all these are output devices. Okay. Next, we'll talk about computer memory. Where does your computer remember things? So memory stores data and instructions for processing. Yeah. And basically, computer memory is divided into main memory or primary memory and secondary memory or backup storage, you can call it, right? In order to understand primary memory, we can say it's fast, directly accessible by the CPU, and temporary storage, you can say. However, secondary memory, although it is slower, but it is kind of permanent storage, and it is basically used for backup of data. Now, under primary memory, we have RAM, ROM. So if you talk about RAM, it is random access memory, a volatile memory, which is used to store currently running programs and data. Whatever applications you open, whatever files you're working in, they all are temporarily stored in random access memory. ROM is non-volatile memory, and it has the boot instructions, firmware, etc. in it. There is also a very fast small memory called cache memory. This memory is located close to CPU, and it temporarily stores frequently accessed data to speed up the processing. Okay. Then comes secondary storage or secondary memory. Uh, all the portable hard disk drives, USB drives, your CDs, DVDs, all these come under secondary memory. Now let's talk about size. Computers, they don't use meters or liters, they use bits and bytes. So, as part of units of memory, we have to have an understanding about bits, bytes, KBs, MBs, GBs, TBs, PBs, and many more. So, the smallest unit of data is a bit. We denote it with a small b, and full form of bit is binary digit. It either holds a 0 or 1 in it, right? So 1 bit means either a 0 or 1, right? Then comes nibble. Nibble is basically collection of 4 bits. So 1001 or 1111 or 4 zeros makes a nibble. Next is a byte. We denote it with a capital B. It is group of 8 bits. Next is 1 KB, which is equivalent to 1024 bytes. Next unit of memory is megabyte, which is equivalent to 1024 KBs. Next is gigabyte, which is equivalent to 1024 MBs. Terabyte is equivalent to 1024 GB, and petabyte is equivalent to 1024 TBs. Now let's talk about types of software and what software is. Basically, software is like the instructions for your computer. Yeah, that enables a computer to perform specific tasks. Now, software is further divided into, system software or application software. So when we talk about system software, uh, it it basically runs the show. Your operating system and tools like antivirus or drivers, they all are part of the system software. System software basically manages and controls the hardware so that application softwares can function properly. Yeah. Under that, we have utility programs, including antivirus, disk cleanup, backup software. We also have device drivers, which are specialized programs that allow the operating system to communicate with hardware devices, for example, printer driver, you know. So, next we have programming tools and language translators. These are basically used by programmers or developers to create, test, and run software programs. So, assembler, compiler, and interpreter, these are language translators. Assemblers, they convert assembly language into machine language. Compilers, they read the entire source code and converts it into machine code in one go. Interpreters, they read the instructions line by line, checks the errors, and then they convert it into machine code. Then we have application softwares. Application softwares is basically what you use normally: MS Word, Chrome, MS Excel. So it is designed for end users to perform specific tasks, right? Now let's talk about operating system. Operating system, or OS, is like your computer's manager. Okay, it controls memory, files, apps, and even talks to your printer. It is user interface that lets you talk to the computer, and it has lots of key functions to perform. For example, memory management, file management, security and access control, user interface management, process management, lots of things that are done by operating system. There are some types of user interfaces available in the market of operating system. For example, we have command line interfaces, we have graphical user interface that you most commonly use, GUI, your Windows, basically menu based is graphical user interface. Touch based interface, these days you all are using your touch screens, right? Then voice based interfaces, gesture based interface. So these are some types of user interfaces for operating systems using which we interact with our computers. And let's talk about Boolean logic. Boolean logic is used in computer systems to perform operations on binary values. Boolean means 0, 1, yes, no, true, false, right? So it is essential for decision making in digital circuits and programming. Now, in order to understand Boolean logic, you need to understand these logic gates, right? Basic logic gates we have is not, and, or. On your screen, we have symbols of all these gates along with their uh, truth tables. So not takes one input and it inverts the input. So if 1 is entered, 0 is the outcome. If 0 is the input, 1 is outcome, right? Now, and it takes at least 2 inputs. It will give us 1 as output only if both the inputs are 1. Okay. Now we have OR gate. OR gate is basically, it will give you 0 as output only when both the inputs are 0. Even if your one input is 1, you will get 1 as output, right? Then we have NAND, which is just invert of AND gate. And we have NOR, which is invert of OR gate. Then we have XOR gate. XOR gate gives you 1 as output when your inputs are not similar. Yeah, it gives you 0 when both the inputs are same. For example, if 0 and 0 is the input, then you get 0 as output. Or if 1 and 1 is the input, then you get 0 as output. So this is all about Boolean logic or logic gates. Now let's talk about number system, basics of number system. Computers, they use various number systems to store, process, and represent data. The most commonly used number systems are, first of all, decimal number system, then we have binary number system, then we have octal number system, then we have hexadecimal number system. So every number system, they have a base. Base means how many unique digits are used in each number system. So if we talk about decimal number system, we have 10 as base. That means 0 to 9, there are 10 unique digits. If we talk about binary number system, base is 2. That means there are only 2 unique digits, 0 and 1. Then we have octal number system whose base is 8. That means unique digits are 0 to 7. 0, 1, 2, 3, 4, 5, 6 and 7. You can make other numbers using these digits, but unique digits are these only. In hexadecimal number system, base is 16, where unique digits are 0 to 9 and A to F. In total, 16 unique digits we have. A means 10, B means 11, C means 12, and so on. F means 15, right? There are some examples given on your screen to understand how the numbers are created using these digits. So have a look. Last but not least, let's talk about encoding schemes. Computers, they do not understand letters like we do. whatever input you give to computer, whether it is in the form of text, whether it's in the form of numbers, whether it's in the form of video, whether it's in the form of audio, everything is converted into binary. So we need some, data encoding schemes using which everything can be converted into binary numbers in binary form, basically. So when we talk about text, so these are the encoding schemes ASCII, ISCII, and Unicodes, which are used to convert textual information into binary equivalents. So there is a table created. You can have a look on your screen. Basically, they all have different bit lengths. They all have different type of characters or languages which are covered uh, by these character codes, right? Have a look, and it's self-explanatory. You can understand once you go through this table. Okay. So that's all for today. I hope in this video I was able to cover basic fundamental concepts of computer science. Let me know, what do you want to learn next? Coding, AI, cybersecurity, whatever you want. Just mention in the comments. And please do not forget to like, share, and subscribe. See you in the next video.